So get out your systems of linear inequalities examples. This was a sheet that you received in class, okay? If you look over, it's got examples 1 through 5, and you'll see some coordinate planes on the front. So go ahead and find the sheet. Now I went ahead and I copied basically all the same problems, so it looks slightly different, but all of the examples are exactly the same. So what we're gonna do is we're gonna run through each problem. You're gonna check the accuracy of your work and see if we can understand this topic a little bit better. So first thing we're going to do for example 1 is we are going to rewrite this inequality in slope-intercept form. All right, so this is the given inequality. The first thing that I'm going to do to both sides is I'm going to subtract 2x. So negative y is less than negative 2x plus 1. Okay, so we got to divide by negative 1 to get the y by itself. When we divide by a negative, we flip the inequality, okay? So that's going to be one of the bigger things moving forward is just remembering that, because if we don't flip the inequality, we're not going to shade the correct way. Negative 2 divided by negative 1 is positive 2x. 1 divided by negative 1 is minus 1. So this is the inequality that we are shading. So we're going to come down here and we're going to plot the y-intercept at negative 1, and our slope is a positive 2. So let's move up 2 units over 1. Up 2 units over 1. Okay, we can reverse it and go down 2 units over 1. Now, when we draw this boundary line, okay, because it just says greater than, we're going to use a dashed line. And let's remember, right, that if it was greater than or equal to, it would be a solid line. So finally with the shading, okay, so the way I think about this is I need to think about where the y coordinates are greater than. So if I put my pencil here on the positive y-axis, this is where the y coordinates are getting bigger and bigger and bigger. This is where they're getting greater. If I put my pencil down here on the negative y-axis, this is where the y's are getting less than because they're getting smaller. Since this is y greater than, I'm going to shade, okay, everything this direction over the y is greater than, okay? So I'm going to essentially shade up above the line. All right, if that makes sense, go ahead and check this off. Let's move on to example 2. Now, what we're doing in example 2 is we're going to solve a system of inequalities. So our first inequality right here is y is less than or equal to x minus 3. Well, this inequality, we need to divide everything by negative 2. And so what's going to happen is y is going to be greater than or equal to, okay, we're going to flip the inequality, negative x minus 2, once I divide each of those terms. So what we're looking to do is we're going to graph each inequality individually, and our solution is going to be the overlap of the two inequalities. So here's my first inequality. It has a y-intercept of negative 3. So negative 3 and a slope of positive 1. So it's going to be up 1 over 1. All right, once we get a good number of points right here, since it's less than or equal to, it's going to be a solid line. Okay, so then we got to think about the shading. Now, again, if y is greater than, I think about putting my pencil on the positive y-axis. This is where your y's are getting bigger and bigger and bigger. If y is less than, I put my pencil on the negative y-axis. This is where the y's are getting smaller. This inequality says x is less than or equal to x minus 3. So I kind of like to do this in colors too. So if you have two different colors, then maybe just lightly shade. What we're doing is we're shading everything less than the boundary line x minus 3. All right, now let's go back and let's graph our second line, negative x minus 2. So we've got a y-intercept of negative 2, but this time we have a negative slope. So we're going to go down 1 over 1, or we can go up 1 and go over to the left. Again, this is going to be a solid line for the boundary line. And what that solid line means, again, is that any point on that solid line is considered part of the solution. Now I'm going to get a different color this time. I'm going to get, let's get in a purple color this time. All right, so what I'm going to look to do is this time I'm going to shade greater than or equal to this boundary line. And greater than or equal to is going to be above the line, so I'm shading in the up direction, okay? So what we can see is we can see where the two colors are overlapping. What I particularly like to do, what I find helpful, is I like to get a highlighter, okay? Or you can just do this with pencil and just shade it darker. But your shaded solution is going to be this region right here where the two inequalities overlap. So whether you do this in colors or you just do this with your pencil, make sure that this region where the two inequalities overlap is shaded dark. And that's what we say is this region right here is the, this is our solution. So any ordered pair in this shaded region makes the inequalities true. All right, let's go down to example 3. If that looks good, let's check this off. Let's keep moving. All right, so example 3. Is the ordered pair -1, 2 a solution of the system of inequalities below? So what we're going to do is when I am given -1, 2, that means that the -1 is the x-coordinate and the 2 is the y-coordinate. So a nice way to do this, rather than having to graph the inequalities, is I can plug the coordinates in. So let's see what it looks like when we plug in -1, 2 into this first inequality. I'm going to plug 2 in for y, and this is 3 times -1 minus 1. So let's keep going. 2 is greater than or equal to -3 minus 1, which means 2 is greater than or equal to -4. And this is true, okay? So the point works for this first inequality. Well, let's come over here and let's see what happens when we plug in our point. So I'm going to plug 2 in for y, and this time it's 2 times -1 plus 2, okay? So now I'm plugging my point into the second inequality. 2 is... Oh, you know what I forgot? I knew something didn't look right. I didn't write the problem down right. There's a negative right here in front of the 2. Okay, so here we go. So this is going to be 2 is greater than or equal to -2 times -1 is going to make +2 times 2, and we get 2 is greater than or equal to 4. This is false. And since this point doesn't make both the inequalities true, our answer is not a solution, okay? So you can go ahead, and that is your final answer, is to say not a solution. However, this work that I did of plugging it in, that's your justification. So when the problem says to show work or to justify, us plugging in the point is the work. All right, so if that looks good, let's check that off. Example 4. So let's try graphing another system of inequalities, but this time we're going to have 3 different inequalities. And what's nice this time is that my inequalities are in the form ready to graph. So let's start by graphing this first line. I've got a y-intercept of 4 and a slope of -2. So down 2, and we head to the right 1. I can reverse this and go up 2 and head to the right. So because of the less than or equal to, my boundary line is going to be a solid line. All right, now let's think about the shading. I have, again, I put my pencil on the positive y-axis. This is where your y's are getting greater. When I put my pencil on the negative y-axis, this is where your y's are getting less than. And so when I go to shade, I'm going to pick my first color. This inequality says less than or equal to, so we're going to shade down here over where the y's are getting negative, over the y is less than. Okay, so then what I'm going to do is I'm going to graph this second inequality. The boundary line is like x equals -3. And so what that means is I put my point right here at -3, and this is going to be a vertical line that goes through -3. Because of the inequality, though, it's going to be a dotted line, which means the boundary line is not part of the solution. So let's think about how to shade for this. Put your pencil on where the x's are getting bigger and bigger and bigger. This is where your x is getting greater than. Put your pencil on where the x's are getting less than. This, okay, where the x's are getting smaller or where x is less than. Since the inequality says x is greater than -3, we're going to shade all this side to the right where x is getting greater than. Okay, so right now, can you see your shaded area is right here in between? Okay, so I'm gonna go ahead and get rid of that. Now we got one more inequality to graph, and then we're gonna identify the overlap of all of that region. This time I think I'm gonna do a yellow color this time. Well, let's start with our boundary line. Okay, so this time we have the line. This is like having the line y equals 1. So while x equals was a vertical line, the line y equals is going to make a horizontal line. So put your pencil where y is equal to 1, and this is going to be the horizontal line that passes through y equals 1. And again, this is going to make a solid line. So let's shade this last time in the direction where y is greater than. Well, y is greater than up here, so I'm going to shade everything greater than. So you just want to be really organized with your shading. I can kind of tell already that mine's, even though I'm doing it in colors, it's kind of hard to see. But what I notice is I have this region right here where all of the shading is overlapping. And so this region right here is where the shaded solution is. Oops, I went a little bit too far. We have to keep our shaded above this horizontal line. The shading is going to be to the right of the vertical line, but it's going to be below this diagonal line. So it's going to end up being this shaded region right here, okay? So either get like a highlighter, get another color, or if you're using your pencil, just make sure that you shade this region the darkest. If that looks good, let's check that off. All right, last example. So the last thing that I'm going to have you do is I'm going to give the inequality, and you are going to write the equations of each inequality. So let's call this right here, let's call this line number 1, just so I can keep this organized. All right, well, line number 1, when I look at it, what I want to see is what the slope in the y-intercept is. It has a y-intercept of 4, okay? So the y-intercept is equal to 4. The slope of the line, we should be able to tell if we pick out, okay, points on the graph. And when I look at this, I actually see that it's going down 1, right 1. That means that the slope is -1. So what we can do is let's put this together. It's going to be y. Now, I do need to figure out what the inequality is. We'll come back to this part, but the boundary line is going to have a slope of -1x and a y-intercept of 4. So finally, we need to figure out the shading. Again, this is where y is getting greater than, this is where y is getting less than. Because everything is being shaded below this line towards the less than, then I'm going to write my inequality, okay, as y is less than or equal to because of the solid line. So let's come over here to line number 2. And what we need from line number 2 is we need the slope in the y-intercept. So I can see right here that the y-intercept is going to equal a -2. The slope of the line, if I look carefully, is actually going up 1 over 1. And so this time we have a slope that's a +1. So let's put that together. We have y. I'm going to leave the inequality for last, but the equation is going to be 1x minus 2. Okay, now let's look at your inequality. This inequality, it's shading above the line, okay? And so that is going to make it greater than. This is going to be greater than because it's going to be just be greater than because it shades above and it's dotted. This is going to be less than or equal to because it's shaded below the line and it's a solid line. So finally, in our last part, let's take our 2 inequalities and let's write a system. Our answer is going to be y is less than or equal to -x plus 4, and y is greater than x minus 2. The order at which you write line 1 and line 2 does not matter. Okay, so when you get to this assignment, you're going to see a variety of problems that cover all of these concepts, and I hope this video helps. So if example 5 looks good, check it off, and that is all of our examples. See you next time.